So in this video, we're going to be talking about counting with numbers and sort of counting how many numbers we can have for a certain amount of value, etc. So let's get started right away. And I'll give an example so it makes sense what we're talking about here. So let's say we want to find how many three-digit numbers which have a zero in them, at least one zero. So we can have 1, 0, 2, 0, 3, 0. And this is similar to our last problem in the last video, where we did something similar with bees in Latin, three-letter words. So this is kind of similar, but we're going to take sort of different steps here. We're going to start off with basically we're going to find off how we're going to see how we would sort of construct such a number. So we're going to start off basic and simple. So for the first digit, it can't start with 0. So in each digit, here we're going to have 1 to 9. And I'm going to explain in a minute right here. The first digit can be anything from 1 to 9, inclusive. So it can be 1, 2, 3, 4, 5, 6, 7, 8, or 9. It can't be 0. If it's 0, then it's not a three-digit number. The middle digit can be anything from 0 to 9, inclusive. So this can have a 0 in it. If we want to, we can have a 0 in here. And same goes for the last digit. It's still going to be a three-digit number if we have a 0 in any one in the middle digit or the last digit. So it's still going to be a three-digit number if we have those cases. So those are possible considerable cases, and this is just for a three-digit number. So we're going to find how many three-digit numbers even are there. So obviously 1 through 9. 1 through 9, we have 9 options. And then 0 to 9, we have 10 times 10. And we can just multiply these. 9 times 10 is 90. 90 times 10 is 900, I think. So 900 three-digit numbers. Right? We know there's 900 three-digit numbers. So with this, we have 900 three-digit numbers. All right? We have 900 three-digit numbers. Now that we know we have 900 three-digit numbers, we're going to find out how many of these numbers have at least one 0. So we're going to put a 900 there. And again, we know we have 900, and we're going to construct such a number. So we're going to start off with one of my favorite problem-solving strategies when it comes to counting, is to subtract off whatever you don't want. So basically, when we don't want, we want to count what we don't want in such a number. When we're constructing a number, we want this is going to be 0 through 9, and 1 through 9, 0 through 9, and 0 through 9. But this is generalizing. This is just equal to that. We can't have that because we want to count how many strictly have at least one 0, or it can be more than 0. So in the last video, we talked about drawing a table and a diagram. In this video, a more efficient way of counting numbers such as this is to do what I'm going to do here in a second. So we're going to find, if we don't include a 0, let's say we want all three-digit numbers without zeros. We're going to have 9. This is going to be a 1 through 9, 1 through 9, 1 through 9. And this is basically saying we can't have zeros. So we have 0 through 9, one-digit numbers. We're going to take out the 0, replace it with a 1, since 0 plus 1 is 1. And we're going to include 1 through 9 numbers. So this is just 9 cubed, which 9 squared is 81. 81 times 9, that's easily computable. 729. So 729 numbers that have no zeros in them. And that's what we don't want. So if you find what we do want, we just subtract it off. Subtract it off. And then we get we can check this. Yeah, alright. So we have 171 such numbers. And that's our answer. I use a highlighter there. Alright. We have 171 such numbers. Alright. So, we're going to try a little bit different of a problem here. Let's say we have a 6-digit number. Actually, no. Let's do a 4-digit number. We're going to work our way up. We're only going to do four in this video. So, let's do a 4-digit number. And a 4-digit number, obviously, we're going to draw 4 slots. So we do in counting. And we're going to count how many 4-digit numbers have at least one 5. And I mean, I don't want 15, I want 1 5. So 1 5, that's pretty simple, similar to our last problem here. In the first digit, first we're going to count how many 4-digit numbers there even are. So first digit can't be 0, it can only be 1 through 9, so that's 9. And then these can be 10, so. And then we just multiply. 9 times 10 is 90. And then we have 90 times 10 times 10. That's 900. 900 times 10 is 9,000. Okay. So 9,000 4-digit numbers. Now, we have 9,000 4-digit numbers. We'll place that up here. And we're going to start counting how many 4-digit numbers have no 5s in them. Well, 9,000 is one of them. We have no 5s. But we're going to count this a little more strategically here. And the first one is obviously going to be a 9. The second option, we can have 1 to 4 and 6 to 9 inclusive. So we can have basically 1, 2, 3, 4, 5. We can't have 5. 4, 6, 7, 8, 9. Yeah, that's what we can have. So that's 1, 2, 3, 4, 5, 6, 7, 8. So we can have a 1, we can have a 2, 3, 4. We can't have a 5. We can have a 0 though. So that's 9. And we know what 9 cubed is. Times 9. And we can just do that out. 9 times 9. Two times 9 is 18. And then 18 scores 22, 26, 5. That should be correct. So we have 6,561 numbers with no 5. So again, we did the same thing that we did in the previous section, or the previous example. We just, we took what we don't want, which is 6,561. So again, get more organized. 9,000. And that's what we're going to be doing. So basically this is 4-digit numbers. And then this is no 5. So here we're just subtracting it off because what's remaining is obviously just going to be what we're looking for. We're looking for every single 4-digit number which has at least 1 5. So we're going to go ahead and do the subtraction here. So this is just 9, 3, 4, there's 2. Okay. So our answer for you subtraction is 2,439. And we're done. So basically, that's what we want to do when we have counting problems with numbers involved, and that's a good strategy to take whenever we have numbers. Next video is going to be talking a little more in depth about this, but yeah, that's counting with numbers.